good morning, good afternoon, good evening, depending on where you have joined from. Welcome to yet another webinar from Data Platform Geeks. My name is Amit Bansal and I'm going to be your host for today. And this is another exciting day today after yesterday's webinar by Bob Ward. And we have another stalwart, another expert with us, Jonathan Kehayias from the US, who is a very, very popular, world renowned expert on SQL Server. He is a Microsoft certified master and an MVP for many years. And I would love to talk more about him, but let me just get quickly over the introduction. Today's session is about deadlocking for mere mortals. Here is a quick overview of who we are and what we do. So I will focus on Data Platform Geeks and SQL Server Geeks, which are communities under eDominer. They were started by me a few years ago, and now they're officially part of eDominer companies. And apart from a lot of free events and webinars that we do for the community, one of our flagship offerings for the community is the annual summit that we organize in Bangalore each year in the month of August. This is Asia's largest data and analytics conference, attended by thousands of people from more than 15 countries. And as we know, pictures speak more than words. Here is a group picture for all of you to see. This was Data Platform Summit 2018 group photograph that we had taken after Rohan Kumar's keynote on the first day. And we precisely had like more than just over 1,000 people in this big room and the keynote overflow room. We will share all these slides with you so you can learn more about us. And I'm very happy and delighted to let you know that we have already announced the dates for next year's summit, Data Platform Summit 2019. And the dates are in front of you. August 22, 23, 24 will be the 3-day conference. And this is going to be followed by preceded by the pre-conference training, which will be on 19, 20, 21. So 6 days of learning. And the contact details are also right in front of you there. And just a quick question on why should you care about this conference? Well, this is an annual event, and this is the place where world's experts join us, MVPs, MCMs, Microsoft Redmond folks come here and teach us. And this is incredible because this is an opportunity to learn from people who are the best in business and an opportunity to learn from people who make the products. So explore more on dps10.com. Pre-registration is open. You don't have to pay anything. You can just go and sign up and show your interest. That's the URL for all of you, dps10.com. That's the place where you can evaluate. Thanks to our core team, Manohar, Avanish, Sandeep, Prince, Surbi, and recently we have Vijay, who has joined from Hyderabad. This is the Data Platform Geeks core team, which helps us put up all these webinars and events together. And we are very heavily supported by eDominer teams across Bangalore and Calcutta. So it's a big team that works behind this community and helps us grow. And I wanted to take a moment to share this picture. All of our team members are on the stage during this conference, this year's conference. So yeah, just wanted to share this with you. Special thanks to Microsoft. They have been a great supporter of our community efforts. And today, who we are and what we do, it wouldn't have been possible without Microsoft's support. Data Platform Geeks is a very fast growing community. We have more than 235,000 members from probably more than 100 countries. So I guess all of you are members. There are more learning opportunities out there on the website. So do explore labs, the videos, and the magazine stuff. These are some groups and links for you to join. My colleague Satya is going to share all of that in the chat window, so you can just click and join. We are also available on mobile. And a common question that we get asked all the time, is the webinar going to be recorded? Yes, it is going to be recorded, and it's going to be available in our YouTube channel. The first link is important for you, youtube.com/SQL Server Geeks. Now, let's talk about our expert, our hero for today, Jonathan. And the bio is in front of you, but let me speak about John myself and what I know of him. So I got acquainted with John a few years back at MVP Summit, and then I've been meeting him at past summits. He is a world-renowned expert in SQL Server, MCM, and MVP. He speaks at global conferences worldwide, and which something he has not mentioned in his bio here is he has written a wonderful series on extended events, and I learned a lot about SQL Server extended events through his blogs, and that's the the best block series I've ever seen. And apart from SQL Server accolades that he has, and you can read more about that, I personally really admire. He's also a drill sergeant in the US Army Reserves, and he did a tour of duty in Iraq in 2004. Incredible personality with us today. So we're really honored and delighted to have Jonathan Kehayias with us. John, it's over to you. Friends, take the best use of this webinar and feel free to talk to him. Let him get over through his slides and presentations, and then please use the Q&A panel to ask questions, which we will be moderating. Thank you, all of you, for joining us. Have a wonderful webinar. Over to you, John. Thanks.
So thanks, Amit. So as Amit said, my name is Jonathan Kehayias. I am a principal consultant and trainer with SQL Skills. I have the I guess, dubious luxury of working with Paul Randall and Kimberly Tripp, Glenn Berry, Aaron, and Tim. We do a lot of instructor-led training events that we call immersion events that are week-long and a few 2 or 3 day events. We're also doing them online now, and we're recording a lot of content for Pluralsight. So if you're interested in any of our content, that's a great place to check things out. I always say this is my yay me slide. The most important thing on this slide, though, is my email address, jonathan@sqlskills.com. Or if you just go to my blog, there's a link there that you can send me an email. If you have a question about anything related to what I've talked about today, feel free to contact me by email. Usually it might take me a day or two to get back to community requests, but I do answer almost every email that I get. So if you have a deadlock question or a problem, feel free to reach out and contact me. I always start this class off kind of with a joke and say everything you need to know to prevent deadlocks. And then I usually say, just use no lock on all select statements. Because I've seen that advice so many times, and I usually just say, are there any questions? All right, well, thanks for attending the session. But the reality is that's not true, right? I always make this joke at the start of the session because it's the number one thing you find online in forums where there's questions about deadlocks. And this is actually everything you probably don't need to know to prevent deadlocks. Because utilizing no lock introduces dirty reads, which might be okay for some workloads, but it's not okay for every workload. And I usually try and look at solutions that don't involve that. So I always say, this is not necessarily the answer. So what we're going to do in this session is talk about a review of locking in SQL Server from a basic level, because you have to understand some of the basics of how locks are acquired and released inside of SQL Server to understand how to analyze deadlocks. Excuse me. Then we'll talk about what a deadlock is, just kind of as a reminder. We'll go through the different ways of collecting deadlock graphs in SQL Server. The great thing is that if you're on SQL Server 2008 R2 or higher, you don't have to do anything to collect them. In 2012 and higher, there's really no reason to turn any additional collection for deadlocks on in SQL Server. They're collected by default. So we'll talk about the anatomy of a deadlock and what's happening that causes deadlocks to occur. And then we'll go through reading deadlock graphs so that we can get down to the nuts and bolts of what's happening and what we can do to resolve some of the scenarios where deadlocks occur, and then different ways of handling or resolving deadlocks. Now, for some terminology, a transaction inside of SQL Server is just a unit of work that gets performed in a database. And transactions are what protect data modifications, ACID properties within relational databases. Locks in SQL Server are our synchronization mechanism for resources that guarantees that a resource is protected from being changed by multiple concurrent transactions simultaneously. Every lock has a mode that defines the level of access another transaction is going to have on a resource while it's being locked. Blocking happens, whenever a transaction requests a lock mode that conflicts with the currently held lock and it has to wait for that lock to be released. And then a deadlock is a cyclic blocking of two transactions trying to acquire locks on resources in reversed order in conflicting modes, which basically puts them in a condition where nobody can win. So within SQL Server, there's different granularities of locking. The lowest level lock that you can get is a RID or key lock, a row identifier in a heap, or a single index key within a single row for a index with a B tree. Then we have page level locking, where a page in the database gets locked. We have partition or hobbit level locking, where our heap or B tree partition gets locked. Object or table level locks, where the entire table is locked. And then our schema or metadata locking. And, whoops, wrong direction. And as we move down this list, the amount of concurrent access that we get to resources decreases. But the higher up this list we are, the larger the number of locks are required to protect the resources. So SQL Server is constantly trying to balance concurrency against the number of locks within the engine, and the lock manager is responsible for that. Locks are acquired at multiple levels of granularity to fully protect the lowest level resource, and that forms what is known as a lock hierarchy. So locks acquire, in this list it's from the bottom up, but it would be considered top down, from the table level down to an individual row being modified as a part of that hierarchy. And if we're looking at just an example of a very basic operation, a single delete that's going to execute and affect one row in a table. To perform that delete, the first thing we're going to do is acquire what's known as an intent exclusive lock. And that intent lock is acquired at the object level. And what that says is somewhere lower in the hierarchy, there's a lock that matters that's making a data modification. And that intent lock is there to prevent anybody from gaining full control or exclusive access to the table in a conflicting mode that would, or in a lock mode that would conflict with the lower level lock that's being held. Then we're going to acquire an intent exclusive lock on the page that contains the row. And finally, we'll get an exclusive lock required for making that data modification. And the intent locks pretty much prevent somebody from getting a shared lock at a higher level that would be in conflict with that exclusive lock at the lower level. And lock hierarchies are really important to understand when we look at deadlocks, because if you see a deadlock at the page or object level that's participating with an intent-based lock, that usually means that some kind of higher level lock has been acquired, and we want to kind of troubleshoot what that is. A great example of that would be lock escalation, where we're accessing a table, and maybe we took a few thousand row level locks, and because the engine's going to continue to have to acquire row locks, it just escalates to a full table lock to continue that operation. That table level lock can become a blocking lock for a lot of operations. And when we see intent-based lock blocking or deadlock conditions, that usually is a sign that we've had some kind of lock escalation event. And that might be the problem that we actually want to go troubleshoot, rather than troubleshooting what else is going on with a deadlock, but not always. Now, SQL Server has a very large lock compatibility matrix in the books online. There's a bit.ly link on this slide that would take you to it. And that lock compatibility matrix pretty much would take up the entire screen if I was showing it, and the text would be incredibly small, so you wouldn't really be able to read it. For the purposes of most deadlock troubleshooting, you don't need to know about all of those different lock types. The most common ones are on the screen. Intent shared, where we're locking a object or page with the intent of reading something lower level. Shared, where we're doing a read operation. Update locks, where we're going to modify a row. And update locks can be acquired before an actual data modification completes, which allows shared access to the records until they're finally changed. Intent exclusive, meaning that we have a data modification happening at a lower level. And you'll notice that intent exclusive locks are compatible with intent shared locks. So we can be modifying one row in a table. We'll have an intent lock at the table level and the page level. And we can read a different row in that table, and we'll still have to have an intent lock at the table level and page where that record is, and they're completely compatible with each other. Shared with intent exclusive is kind of rare to see. I don't see it very frequently, but it's listed here because it is one of the more common types of locks. And then exclusive locks where only one thing can access that object, page, or record at any point in time. So a deadlock is basically just a condition where two or more processes are holding locks on resources and waiting for the other to release. So we have process A accessing, excuse me, I'm so sorry, resource 1, process B accessing resource 2, and they acquire locks on those to prevent concurrent access. If process A then tries to access resource 2, it's going to be blocked by the lock held by process B. If process B tries to access resource 1, it's going to be blocked, and we have what is basically a deadlocking condition because neither one can complete or release the lock that it holds because it's waiting to acquire another lock and being blocked. And this is not something that is just specific to SQL Server. Deadlocks can happen in C# code if you have multi-threaded applications. They can happen in C++. And it really is a factor of controlling the order of operations in code and making sure that you don't run into these conditions. Because essentially what you'll have is two threads that can never complete. They'll wait till infinity unless something intervenes. So within SQL Server, deadlocks have a lot of misconceptions. One of them being that deadlocks are a bug inside of SQL itself. There's a rare case where that actually is the end result of the analysis, and it's a special case called an intra-query parallelism deadlock that happens on a single query that deadlocks itself with parallelism. Otherwise, they're not bugs inside a SQL Server. They're usually just schema design issues or code access issues that we can work around. There's also some misconceptions that deadlocks cannot be prevented. I always say that I have yet to find a deadlock that I can't offer a workaround or a solution to. But I found a lot of developers and DBAs that are hesitant to make the code changes that are required to be able to eliminate or solve deadlock problems in SQL Server. Using no locks on all select statements is the best way to prevent deadlocks from occurring. That might work, but there's a trade-off. But it doesn't work if you have an update deadlock. I've seen a lot of forum posts over the years where I see update with no lock. And I always just kind of chuckle to myself because there's no such thing as a non-lock data modification within the traditional implementations of SQL Server. If you're using in-memory OLTP, Hackathon, some of the newer features, there's different behaviors. But when we're talking about just a traditional row stored database with a B tree or a heap allocation mechanism, you have to have locks to make data modifications. So even though it allows you to do a no lock hint, an update with no lock still requires locks. Adding covering indexes for every type of query can prevent deadlocks from occurring. That might be the case, but I've looked at plenty of databases over the years consulting where they've just been totally over-indexed to death. My favorite usually is every index is preceded with _DTA _index_, which means that every time a problem came up, somebody took a query, ran it through the database tuning advisor as a single point query, and the way that tool works is it's designed to do a full workload analysis, and it makes recommendations to make whatever workload it was given faster. If you give it one query, it will make recommendations specific to that one query to make it go faster, and it doesn't care about all of the other indexes that might be overlapping or similar in nature that are there. It'll just continuously create new indexes. And the worst table I saw had 14 columns with 42 non-clustered indexes on it. And there's a lot of excess maintenance that has to happen as a part of that implementation. And a lot of those indexes were only different by one or two columns. So they could be collapsed into a single index structure that meets the needs of multiple queries without having the overlap or excessive storage requirements. And the last one, troubleshooting deadlocks, is a complex task. It actually isn't. It doesn't require a lot of experience. I learned to troubleshoot deadlocks in SQL 2000 timeframe when we didn't have all of the additional features and tools that are available that really make troubleshooting deadlocks easier today. You used to have to turn on trace flags and harvest information from the error log and collect SQL server-side traces so that you could analyze through the information. Today, starting in SQL 2005, Microsoft really made some headway into deadlock analysis and troubleshooting with the introduction of trace flag 1222 and the XML deadlock graph, which typically contains almost everything you'll need to troubleshoot a deadlock if you know how to read through it. So that's what we're going to focus on. Now, inside of SQL Server, the lock monitor thread is what is responsible for handling deadlock detection and resolving any deadlocks that happen to be occurring. It initiates a periodic search every 5 seconds by default. And what it does is it walks the lock hierarchy inside of SQL Server. And what it does is anytime that it identifies that blocking is happening, it does a recursive search to identify if there's a deadlock. So when it identifies that a session is blocked, it checks the blocker and sees, is it waiting for a resource that's already being held? And if it is, it initiates a deadlock resolution. Every time a deadlock is detected by the lock monitor thread, the search interval decreases from its 5-second default down to as fast as every 100 milliseconds inside of the engine. So the more frequently deadlocks are happening, the faster the lock monitor thread is searching for them. Can actually go into what I call definitive search and destroy mode. One of my favorite applications for that was SharePoint. And during an index crawl, SharePoint, because of 2 missing non-clustered indexes, was very common and prone to deadlock conditions. Was it a problem for SharePoint? Not really, because Microsoft wrote defensive code around that. And if they get a deadlock, they just simply retry the operation. And a lot of times the locking semantics are different the next time the operation goes through and it succeeds. So they just log that it happened. But if you watch the lock monitor thread activity during a SharePoint search crawl, it's very active and it's constantly resolving deadlocks inside of the engine. If the lock monitor thread does a search and it doesn't identify a deadlock, it'll slowly start to increase that search interval back out to the 5-second default so that it's not just constantly spinning. So as we go through the demos, one of the things that I'll point out is the first few demos usually take a couple of seconds to trigger. But as we start generating more and more deadlocks, you'll notice that they get detected and they get killed much faster, sometimes almost in near real time. So we'll see that behavior a little bit. Now, the only way that you can really control things related to who is going to become a deadlock victim is through a session-level property called Deadlock Priority. And one of the challenges with Deadlock Priority is that anybody can set it. They don't need any special permissions. It's not possible to block somebody from setting Deadlock Priority. So this is something that I always say, use with extreme caution. When I was a business analyst years and years ago, about 14 years ago, just starting out with SQL Server, I had access to production SQL servers with way too many permissions and with way too much control and little to no code review. And I wrote this report at one point that it would take about 4 hours to run. It had like 14 nested cursors to try and figure out the cost of a problem inside of our system. The reality was I was probably creating more expensive problems just running this code. But at one point while it was running, I got this really nasty red 1205 error that said your transaction's been rolled back, and it stopped running. So I had to run it again, and then it happened again. And I did some searching online, and I found out about this feature called Deadlock Priority, and it became my new best friend. And I learned that if I set my deadlock priority to high, my report never had a problem. It always ran. What I didn't know was the impact that that was having on the rest of the system. And a few days later, our DBA came in and said, "Hey, what are you doing?" And I had no idea what he was talking about. I happened to be working on something completely different. And I said, I'm just writing this specification for change. And he's like, "No, you're doing something in the database. Everybody's getting killed. What are you doing?" And I said, "Nothing." And he's like, "Open that up. What is that?" And I said, "Oh, I had this problem and I found this stopped it." And what I didn't know was that I had prevented every write from happening to our database because I set my deadlock priority high, and anybody with a lower deadlock priority then becomes the victim. So this is something I learned a very early lesson about. And I always say, if you're going to set deadlock priority on a session, the best thing to do is to actually set your session priority to low. The reason for that is, if you set your deadlock priority to low, that almost always guarantees that this piece of code is going to be the piece of code that fails. Why would we want this piece of code to fail? Because I can put try-catch logic around it and tell it to retry that operation. I have more control over saying, I want this piece of code to fail, than if I say, I want this piece of code to win. I have no idea who's getting killed as a result of that. This is the way that the distribution agent for transactional replication works. It actually runs at a low deadlock priority. And if it deadlocks applying a change to a subscriber, it will actually go into retry mode, and it just retries the operation, and most of the time it catches up and it completes. But it does slow things down a little bit. So that's something to watch out for. When the lock monitor thread detects that there's a deadlock, it has to choose one of the threads as a victim. And the victim thread is always killed, and the transaction that's active is rolled back, and a client receives a 1205 error. The deadlock victim is going to be based on a number of criteria. The first one being the deadlock priority of the two sessions. Whoever has the lowest priority is going to be selected as the victim. If they have the same priority value, then it becomes the transaction that's least expensive to roll back. And that's based on the amount of transaction log that has been generated by the sessions. This is why most of the time select statements become deadlock victims, because they have no log associated with them. They just have locks that have to be released. So that's kind of desirable behavior when you think about it from a terms of, do we want writes or reads to fail? Having a read fail probably isn't a bad thing. If somebody's making a banking transaction and the write fails, that's not a good thing, because now maybe something completed on the other end of the application, but we're not reflecting that in our data. So to collect deadlock graphs in SQL Server, there's a lot of different things that are available. Trace flags go all the way back to SQL 2000 timeframe with 1205 and 1204, and I still see people that use those in SQL 2016 and higher. Trace and Profiler have events for deadlock graph collection, event notifications, and WMI do. And starting in 2008 R2, extended events collect deadlock graph information as well. And the system health event session is actually collecting the XML deadlock report on every instance of SQL Server by default. It's there. Usually I say there's absolutely no reason to turn any of the other features on unless you're looking to automate things. And a lot of times then I go to event notifications. I'm not a fan of using trace flags anymore because they output to the error log. So that kind of bloats your error log with a lot of information that you could get another way without any real impacts to the system. So the first thing we're going to do is jump over here, and we're going to just go through the different ways of collecting deadlocks. So if we turn on trace flag 1222 and we look at our trace status, that trace flag is enabled at the session scope now. Is that really helpful to us? Most of the time, no, because that means that only this session is going to output our deadlock graph victim information if it was involved in the deadlock. So what we want to do is turn it off and turn it on globally with a -1 as well, or a -1 flag as well. And if we look at that, now we'll see that it's enabled globally. So that's going to work across the board for SQL Server. And one thing I'm going to do really fast is I'm going to run this reset script just to make sure everything is clear, and I'm going to turn this back on. So event notifications are one of my favorite ways of collecting deadlock graphs. I usually create them inside of MSDB. Event notifications piggyback on top of Service Broker to allow automated processing when events happen. So if we enable the deadlock graph event, I usually create these in MSDB because MSDB is already enabled for Service Broker, and it's the home for database mail. And a lot of times I'll put a activation procedure on the queue that says when a deadlock comes in, send me an email so that I get a notice and attach the deadlock graph to that email. But if we enable our event notification and then query sys server event notifications, we'll see that we have our capture deadlock notification going to our deadlock graph service. If you use WMI, you can enable WMI events in SQL Server Agent and have the Windows management instrumentation capture deadlock graphs. I usually don't set this up, but there is an example in the demo scripts that you can use that will write the deadlock graph to a table within the database. I don't turn this on for a couple of reasons. Number one, there's additional overhead for WMI. And usually I forget that it's here. And when I'm doing other demos, it kind of starts to become a bottleneck or an issue for the WMI polling. The other thing is it runs on top of event notifications. The entire mechanism for feeding WMI alerts is event notifications in the engine. So why not just use that native event notification feature instead? But some of the third-party applications use agent WMI alerts for deadlock capture information. So what I'm going to do is I'm going to read the error log really quick, and it shows us that we've started our instance up and that we have our trace flag turned on. And now we're going to talk about probably the easiest type of deadlock to generate. And I don't necessarily think that this is the most common deadlock, but some people argue with me about it. And basically, it's just a reverse object order deadlock where two processes are going to access objects in reverse order. We have table A and table B in our database. Process modifies data in table A and updates every record. It's going to acquire an exclusive lock. At the same time, process B comes in and updates table B and tries to acquires an exclusive lock for that modification. Then process A will try to update, or process B tries to update table A and gets blocked. And because it's blocked, it's going to have to wait, but it's also holding its original locks on table B. If process A then tries to update table B, we end up with our deadlock condition. And a lot of times I see these deadlocks, I mean, they do happen. A lot of times there's no rhyme or reason for why process A access table A then table B, or process B access table B then table A. Usually where these show up in customer environments that in my experience has been somebody implemented process A years ago and somebody just wrote process B and it got deployed, and now it's creating a problem. And in this case, whoever has the least amount of transaction log generated, for the purposes of the demo, table B will only have one record, so it has the least amount of log generated. It becomes the victim, its transactions killed or rolled back, the session's terminated, and the locks release, allowing process A to finish its update to table B. So to set this up, we're going to create a database called Deadlock Demo. And in Deadlock Demo, we're going to create table A, and we're going to create table B. We're only going to insert one record into table B. We're going to insert 1,000 records into table A, and remove a couple of rows. Table A will have a clustered index on column 1. It'll have a non-clustered index on column 2. And we're going to create a couple of stored procedures to simulate the next type of deadlock that I'm going to talk about. This takes just a second to create. And then what we're going to do is we're going to open up our 2 sides of our processes. So process A, we're going to run in a transaction, and it has a tag here that just says run other window. So we're going to update table A. That affected 999 rows. We're going to run process B, and we're going to update table B followed by an update to table A. And right now, this is not completing. And the reason it's not completing is we're being blocked by process A for table A. So if we go back over here and we run our secondary update to update table B, we have our deadlock. So process ID 61 was deadlocked on lock resources with another process. It's been chosen as the deadlock victim. Rerun the transaction. So this is the error that a user is going to get. And if we go back to our retrieving deadlock graphs and read our error log again, now we have our deadlock list information, which I'm going to copy out and paste into a new window. We're going to come back over here and just roll back this transaction so that the locks release. And I'm going to close those out. We'll close that out as well. So what I'm going to do is I'm going to grab the event notification XML deadlock graph. And I'm going to pop that open. And the reason that I open these up is I like to show that no matter which way that you're grabbing deadlock graphs, with trace flags, if I was to grab a profiler trace, it would have this exact same XML document. The information between these 2 windows is identical. The only difference is one of them has XML tags, one of them doesn't. So whichever way you collect the deadlock graph, it's useful for troubleshooting a deadlock. The information that's output by the engine or the lock monitor thread is consistent, with one exception. Extended events has a different format. So if we go to our event file and we view target data, and we're going to do a filter field name equals XML deadlock report. Here's our deadlock graph. And if we double click that, it'll pop open our deadlock graph in XML format as well. Now, I like to show this because if you compare, let's pop this over here, this to this, there's a difference here. And that difference is this part of the graph right here. Extended events was updated to support what is known as multi-victim deadlock resolution. And that's where you have more than one process that's selected as a deadlock victim that gets killed. This will list each of those processes individually. But you'll notice the process ID is the same between these. It's the same graph from process list down. The only difference is this victim list that allows multiple victims instead of multiple deadlock graphs. It's all one concise thing. And the only place you get that is through extended events. So regardless of which way you get the deadlock graph, one of the first things that I usually do is grab whatever the victim process is, copy it, and then do a replace. And I replace it with the word victim. And I do that for a couple of reasons. One, that process ID is kind of hard to track, and it can be really difficult when you have one of the sessions involved with parallelism because there's multiple processes under a parallel task. But it lets me collapse my processes up, and then I come down to my resource list. The resource list is where you're going to understand what is happening with the locks that leads to a deadlock condition. So I usually come straight down to the resource list, and this tells me that I have a key lock held by our successful transaction on table A on the clustered index. And my victim transaction owns an exclusive lock on table B on the primary key, just by naming convention. The victim is waiting for an update lock to table A. So when I see two objects involved in the deadlock, usually that means that there's some kind of reverse order that's happening. This is where we'll come back up to our process list and look at what each of the processes was running. So I can see the victim process updated table A and then, or table B, then was trying to update table A. But for the process that succeeded, I only see the update to table B. So I don't know why it accessed or was holding locks on table A just from the graph information. But because of the key lock information here, I know that there was an exclusive lock on table A. So it had to have done some kind of data modification. Sometimes it's necessary to go back to the application code. If this was a stored procedure, it would have the stored procedure information and object ID information. So using that, I can go look at the full set of code that's running potentially, or I can request additional information. We're going to see that in just a minute when I run the next kind of deadlock. If I want to know why the victim was selected, the log used here versus the log used here is a telltale sign. But what we also want to look at and scroll over to is what is our priority. This is a place that some people really get confused because there's two different priorities. There's our task priority, which has nothing to do with deadlock resolution. And then there is our session deadlock priority, which here is 0 and here is 0. So as long as the priority value is equal, don't worry, don't get confused by task priority. I wish that the order of these was reversed so that the one that matters was closer to the front of the XML, but it's not. Then we're going to look at log used. And we know that this one did the most amount of change because it has 364,040 bytes of transaction log space. So for this type of deadlock, we're going to really look at the statements. And if we just simply reverse the order of operation, this deadlock goes away. So it's kind of an easy one to fix when we run into that kind of situation. What I think is a more prevalent type of deadlock, though, is either a key lookup or bookmark lookup deadlock. Key lookup being for a clustered index. In older versions of SQL Server, there was an operator called a bookmark lookup. Today, it's a key lookup as well. That's the row identifier lookup for a heap. And this is essentially the same thing as a reverse object order deadlock. But instead of being tables, it's on indexes. So this is what I consider to be the more common type of deadlock in SQL Server. It's also the type of deadlock that SharePoint would run into during index search crawls. So we have a process that's modifying data in the table, an insert, update, delete, it doesn't really matter. It's going to acquire an exclusive lock on the clustered index to make the base row modification. At the same time, and timing is really like almost nanoseconds of each other. A process executes a select statement against that table. The select statement is highly selective, and there's a non-covering, non-clustered index on the column that's being used for filtering. So it can do an index seek against that index and acquire a shared lock, but it's returning additional columns not covered by that index. So to return those columns, it has to do a key lookup back to the clustered index or heap. To do that, it's going to have to acquire a shared lock there. And because of the exclusive lock that's in place for the data modification, it's going to be blocked. If we're modifying data in the clustered index, what else do we have to do? We have to maintain the non-clustered indexes. So we're going to have to acquire exclusive locks there. This is where we end up with a deadlock condition on a single table. Because the select statement has no transaction log generated, it's the deadlock victim and rolled back as long as the priority is the same, allowing that insert to complete. So if we jump over to our demos, and I'm just going to close those out. We're going to pull up our select process. And what I'm going to do is I'm going to run this, and we're going to grab our execution plan really quick. So if we look at our execution plan here, we have our key lookup and our index seek. So our index seek is against table A, column 2. And then we're looking up against our clustered index to get column 3 because it's not covered by that non-clustered index. So we're going to open up our update. We're going to start this, and then we're going to start our select process. Actually, turn off the execution plan. So it was detected as a deadlock. It took about a second for it to do. We're going to run it again. Took it 2 seconds. Run it again. Took it a couple of seconds. But now, pretty much as fast as I run this, it's going to detect the deadlock and kill it. And that's the search interval of the lock monitor thread responding to the fact that deadlocks are occurring in the engine. And it's searching more frequently, and it's going to pick up the deadlock. Sometimes it takes us, the locking semantics just don't hit right for this to catch as they're spinning around each other. To trigger this type of deadlock, you really have to run this in a loop. You can't just create one condition because the engine does all of the locking and releasing so fast. It's timing dependent. So let's go back to our system health event file, view our target data. Nothing showed up. Well, the reason nothing showed up is it takes time for the events to dispatch out. It can take up to 30 seconds before the system health event file is going to show the deadlock information. But if we come back over here and we go to our event notification queue, we have our deadlock graph available. And we can just pop that off of the queue. So what I'm going to do is while we wait for extended events to buffer out its information, I'm going to do my replace and some analysis of this deadlock graph. So we're going to replace it with victim. We're going to come down to our resource list. And I always use this as an example because this is a pattern that you should recognize if you're looking at deadlock graphs. And basically, when we look at our resources, table A and table A, one is our clustered index or primary key, and the other is a non-clustered index. If you see this marker, the odds are you have a bookmark or key lookup deadlock. Usually the victim only has shared locks. It's driving on a non-clustered index, so it owns the locks there. And then it's requesting a shared lock on our heap clustered index primary key. And then we have an owner with a modification lock that's requesting access to the non-clustered index. So we're going to close those up and come back up to our process list. Again, if we look at our priorities, priority 0, no log generated. That's why this is now the victim. Because I was executing stored procedures, the execution stack frames tell us the names of those stored procedures. In some cases, if you're doing this through a RPC call or a SP execute SQL from the .NET SQL client, instead of it having the input buffer, it'll just have the object ID associated with the stored procedure that's running. That's fine. You can take that, query the catalog, figure out the name of it, and then go get the code for that procedure as well. But this shows us within our execution, this is the command that we sent to SQL, but this is where it's actually running into the deadlock. So our bookmark select is outputting column 1 and column 2, and it's filtering where column 2 between column 2 and column 2 plus a value. Our bookmark lookup update is just updating the table and changing values for the records. So let's look at our victim process, and if we were to go pull the execution plan either by SQL handle or just by generating the execution plan for the statement that's running, what we would see is that we have the key lookup operation that's happening. So how do we prevent that? Well, there's a few things that we could do, right? One of them would be we could do set our transaction isolation level to read uncommitted. And if we execute this now, I always forget. There we go. I can't spell. So if we run this, nope. There we go. If we run this now, this is essentially putting a no lock on the select statement, but we're doing it at the transaction isolation level scope. And if we come back over here and we run this, will we ever get a deadlock? No, we won't, because this isn't locking those records for reads. But we could be getting dirty reads, which may or may not be acceptable to the application. But this is where the information about using no lock kind of is accurate, but there's a trade-off, and nobody ever explains what that trade-off is. So I always assume that the person asking a question on the forums is very new to SQL Server and may or may not understand or know the pitfalls that are there. It's not because I have some huge ego or anything else. I take the assumption that somebody just doesn't know because I didn't know when I started. And if somebody didn't tell me, watch out for this, I had no idea. So I usually try and educate along the way when I'm answering questions and just say, you know, hey, this does this, but the trade-off is this. So this will allow it to run, no problem, as far as our deadlocks go. But it might not be the best solution for our business. So if we go to our execution plan and we look at this key lookup here, the tooltip actually will tell us why we're doing that key lookup. So it has our output list. So one of the things we could do, instead of doing transaction isolation level read uncommitted, if we go back to our table, table A, go to our indexes, one of the things we could do is include column 3. Set drop existing on. And if we run this, what happens to our execution plan? Well, now, can this ever deadlock? No, because we're not crossing indexes, right? We made this a covering index. This is where using DTA to solve a deadlock helps people out, but it's also where you can run into issues with excessive indexing and duplicate indexes or redundant indexes. So I always kind of watch out for that as well. That's something that could be potentially problematic. So what I'm going to do is I'm going to reset that index. Let's put it back. And we're going to talk about another option, which would be leveraging read committed snapshot or snapshot isolation so that we use row versioning and TempDB. Depending on the workload, this might be one of the better ways of solving deadlocks. Again, it's not without trade-offs. You're going to use row versioning and TempDB. A lot of people are really hesitant to use snapshot or read committed snapshot isolation because of row versioning. But I always point out today that since SQL 2012, every readable secondary for an availability group leverages read committed snapshot isolation under the covers to allow that read-only workload. If there are literally tens to hundreds of thousands of readable secondaries that have been deployed since SQL 2012 launched. If those can handle the TempDB overhead for recommitted or snapshot isolation as a part of the readable secondary workload, a lot of times you're probably not going to have to worry about that on the regular workloads that are out there. I always say the proof is kind of in the pudding. Prior to 2012, a lot of people were very hesitant to make use of snapshot or recommitted snapshot isolation because of the TempDB impacts. But with 2012 onwards, that impact has been shown to not necessarily affect a majority of the workloads that are out there. So if we enable recommitted snapshot isolation, and we come back over here and just look at our execution plan, we have our key lookup, so we can run this, and we can run our bookmark lookup scenario. I have to run it a second time because I kicked everybody out. But these two, again, are never going to block because now this is utilizing the row version in TempDB for accessing the data. And I have to turn the plan off or Management Studio will crash. So we've already talked about 3 different ways of addressing this type of a deadlock, right? We could make an index change. We could make an isolation level change to read uncommitted. We can use recommitted snapshot isolation or snapshot isolation inside of the database so that we use row versioning in TempDB. Multiple ways that you can solve a problem. Which one's right? It depends on the workload. If you have a application that uses an object relational mapper or ORM and generates its code on the fly and allows a lot of user customization of what's going to happen, it might be really hard to build an indexing strategy that meets the different queries or permutations that are there. That's where recommitted snapshot isolation might really help out with mitigating or eliminating deadlock conditions inside of the server. If it's deadlocks related to reporting, can you offload those reports to a transactional replication subscriber maybe so that the read operations aren't happening and you have minimal latency updates of the data? Offload it to a readable secondary if you want to pay the Enterprise Edition licenses with availability groups. There's so many different options for handling read-based deadlocks that can be implemented, and it just depends on what's the best case. But the root of troubleshooting, it is always coming down to this resource list and looking at what objects are involved, what indexes are involved, and then what lock modes are involved. If you have an application that requires or relies very heavily on triggers, this can be a little more difficult to troubleshoot. But the nice thing is, if there's nested executions, there'll be additional frames inside of this execution stack that lets you unwind back to the original call, and then you can dig through and see this did this, and then it ran this, and then it executed this, and this is where the deadlock happened. So when I see multiple frames in that stack with multiple procedure names or multiple object names, a lot of times I say, you know, are these triggers? What else is happening? And it's easy to introduce deadlock conditions with triggers because this insert does this, and then that triggers this, and then that triggers this, and then boom, we're back to modifying the same table, and we have a deadlock condition. So digging through that framed information in the execution stack is really important sometimes. Now, the bug in SQL Server is what's known as an intra-query parallelism deadlock. And this is just a deadlock between parallel threads in the same session. It's usually a bug in query optimization that may or may not be easy to fix. There's a great blog post by a guy named Bart Duncan at Microsoft that talks about intra-query parallelism deadlocks from, I think he wrote it in SQL, like the 2007, 2008 timeframe. And it was actually sparked by a deadlock graph that got posted to the MSDN forums. And I used to answer thousands of questions on the MSDN forums when I was a lot more active with answering forum questions. And I'd never seen that type of deadlock graph before. So I actually reached out to Microsoft and Bart Duncan because he was the deadlocking guru at Microsoft at the time and said, hey, you know, what is this? And he wrote this really long blog post that talks about it. The way that you can identify it is the deadlock resources will be on Exchange event resources only, and they always have the same SPID. If you see a deadlock graph that has multiple processes with the same SPID, and there's one process on a different SPID, it's not this bug. It's just a deadlock that involves parallelism. But if every process has the same SPID, it's an intra-query parallelism deadlock. The only things you can do is work around it, either by introducing an index change or rewriting the query so you get a different execution plan, reducing parallelism, all the way down to max stop 1 in some cases. But if your server level DOP is at 8, try running the query at 4. That might be enough to allow it to still use parallelism but not hit the bug. In a few cases, I've had to make queries run at max stop 1, or find a way to rewrite the query. Introduce a temporary table with an index that changes the query plan shape, something that changes the way the optimizer runs that query, or optimizes the query and the execution engine runs it. So to resolve deadlocks, we can change indexes, we can change isolation levels, so readers don't block writers, writers don't block readers. We can use dirty reads, we can use locking hints to force specific types of locks to prevent lock conversions in some cases. There's a lot of ways to go about resolving deadlocks. But one of my favorite things to do is write defensive code. You can use a try-catch block in T-SQL to handle 1205 errors when they occur. All you have to do is read the error number, and if it's a 1205, figure out a way to handle that deadlock. ADO.NET can also handle deadlocks when they occur by catching a SQL exception. And it's going to raise a 1205 error. The number property of the SQL exception gives you the error number, and you can decide what to do. A lot of times, if there's a specific piece of code that's prone or problematic to deadlocking, that's where I use deadlock priority. I set it to low, I put a try-catch block around it, and then I introduce retry logic so that it will re-attempt the operation. Typically, the types of locks that are being held are very short duration, usually within milliseconds or microseconds. They only exist during the initial iteration of the transaction. So if you resubmit that command, the lock semantics of the other side of the deadlock are different. It usually is going to succeed. So where the actual application logic is not easily changed or can't be reordered, just putting a retry block around the transaction can be really, really useful. And you want to log that the deadlock occurred so you can do analysis and make sure that you don't hit it in an infinite loop. But there's a really simple pattern for this that can be reused. And I've deployed this pattern repeatedly. 2012 and higher, I don't use this piece of code. I just use throw so that it will throw the error back out. But if you're on 2008 R2, that isn't an option. You have to pull the information and re-raise the error back out. What we're going to do is we're going to introduce a loop, and we're going to allow up to 4 retries. And as long as we haven't exhausted our 4 retries, we're not going to accept that we got a deadlock. So we're going to try, and it says place SQL code here. All you do is replace this execute block with whatever your code is. If it succeeds, we're going to set retries to 0 to jump out of the loop. We could also just use the command break. We don't need to return this select. It's just there for demo purposes. But if we end up in a deadlock, we're going to check, is the error number a 1205? If it is, we're going to decrement the retries by 1. When retries hits 0, we're just going to accept that we've had a failure. Otherwise, we're going to decrement by 1, let it retry. It's usually going to succeed. If it's not a deadlock, though, we want to throw that error back out. We don't want to just catch every exception and say, oh, we're going to swallow that and hide it. We want to make sure that as a part of defensive coding, we are allowing real errors to pop back out. And in the catch block, we're going to check our transaction state and just we're going to roll back if necessary as a part of that and allow it to loop. And I've implemented this dozens and dozens of times just as a fast fix to deadlock code. One of the things that I usually do is I change this comment and put this code runs in a try-catch block for deadlock handling. Why? Because it's going to pop up here. and that comment will show up as a part of the execution stack, and I can see immediately, I've already handled that. I can ignore this because the deadlock graph is always going to generate. When the 1205, we're not preventing the 1205. We're not preventing the deadlock. We're just making it not a user problem. So by making it not a user problem, we want to have something that allows us to catch the fact that, hey, we've already handled this and we don't need to waste our time digging through those deadlock graphs. So some takeaways from this session. First, most deadlocks aren't a bug in SQL Server. If you can understand how to read the information in the graph, they usually can be prevented. Second, don't just blindly use no lock on select statements or add indexes. Look at the root of the deadlock and then look at the workload before you decide on any fix or any change that should be made. And whenever possible, I'm a big fan of defensive coding. I am a huge fan in both C# and application tier logic, middle tier logic, and database tier logic of making sure that you handle errors and exceptions appropriately so they don't bubble back out to the end user as this big red message that something's not right. If you can adjust your code for that, a lot of times it provides such a better end user experience. Now, there's a lot of resources. Bart Duncan's blog posts are still some of the definitive sources of information on deadlock troubleshooting. There's a Pluralsight course that I've recorded that's about 2.5 hours long that includes 5 or 6 other different scenarios for deadlocks that we just don't have enough time to go through in a simple user group or online session. There's some posts I've written on SQL Server Central and some things on my old blog on SQL blog. And I always like to wrap up with one of my favorite community contributions for blog posts or deadlock graphs. But I believe I'm going to have to change virtual machines really quick to pull it up. Where is my virtual machine? So we're going to come up here, drop this down, and I thought I had it inside of here, but it's not in this VM. So I'm going to boot a 2012 VM up, and while that's booting, I'm going to go look at our Q&A. Vivek said, does SQL isolation levels help to ease the deadlocks? They can. It all depends on the type of deadlock scenario. So where I talked about using read uncommitted and read committed snapshot isolation, that helps with reader-writer deadlock conditions, where readers are blocking writers or writers are blocking readers. It doesn't help with the writer-writer deadlock. If you have a true writer-writer deadlock, that is a scenario that you either have to change the order of operations or you have to do something that addresses that deadlock condition. What that is depends on a lot of different factors. Writer-writer deadlocks are a great place that I sometimes will go introduce a try-catch block just so that I know that it's being handled and that it's not bubbling out as a problem to the end users necessarily. Ravi asks, can we use with recompile option for stored proc or any query hints? Can we make any difference for deadlocking? Recompile, I don't want to say that it can't affect a deadlock condition. It might if you have what I would deem to be a parameter sensitive workload issue, where parameter sensitivity is what leads to a deadlock happening, but very rarely is it related to like a parameter sensitive plan issue. A lot of times it's more related to just the means of access. So under a parameter sensitive plan issue, your typical execution plan would look like an index scan over a table. And for certain parameter types, it's selective enough that you get that key lookup, that would be the only condition I could think of where a recompiled or a difference in plan would affect the deadlock behavior. It'd be very rare for that to be the case. I'm just trying to think. Typically, my answer for that would be no. Srinivas asks, what is a table spool? That is a really good question that offhand I can't answer with 100% accuracy, so I'm not even going to try. If you send me that question by email, I can send you some references. What I would tell you to look for online would be articles by a guy named Paul White, either on SQLperformance.com or on SQL blog. Paul White is a query optimizer expert. He knows way more about how queries are optimized than even some of the guys at Microsoft. I would honestly say he's incredibly smart, but he's written articles about spools, the different types of spools, why they're introduced, why what optimizer rules will introduce a spool, and what their effects are and how to tune those. And that would be the source that I honestly would have to go look that up. As much as I know about SQL Server, I still use Google and Bing like crazy all the time. My least favorite thing is to go Google a topic and I land on my own blog post I wrote 10 years ago. And I just shake my head and go, how have I forgotten this? But it happens, right? There's so much information about SQL Server. It's such a broad platform. It's impossible to be an expert across the board anymore. Years ago, I used to think that, I understood the feature set of SQL Server really well. And today, I'll just tell you, if it's outside of the core storage engine, I don't know it anymore. It's just impossible. Pradeep asks, can a fragmented index lead to a deadlock? Usually no, but it's possible. I don't like to say, anything is definite. It's always an it depends. It's possible that traversing the row structures would lead to locking in a weird order that could lead to a specific type of deadlock. But a lot of times deadlocks are not related to fragmentation. They're related to order of access. And fragmentation definitely could affect it. It would not be one of my first things to even think about if I was looking at that as a problem. Why is recommitted snapshot level not used much by Prabir? Primarily, I honestly would just tell you that TempDB being a single resource in SQL Server, a lot of people get fearful of doing anything that says that it could use TempDB heavier. And because of row versioning going through TempDB, there's always been a fear that has existed there in my experience that has prevented people from actually using that as a feature. It doesn't mean that it's wrong. It doesn't mean that one way is right or not. It depends on the workload. In my 14 years of working with SQL Server, I've only seen 2 instances where recommitted snapshot was a bottleneck or a problem for the workload, and they're very heavy update-based workloads. They're not your typical workload at all. If we use more covered indexes, is there any performance effect from Santosh? Yes, there can be. Every index is a copy of the data, right? If covering indexes, especially with really long included column lists, can become a duplicate of the table. That's one of the challenges with DTA recommended indexes, is it'll create a non-clustered index on one column or key and include every other column in the table because the query pattern is a select star. That's an exact copy of that table. Is that ideal or what you want it to do? A lot of times I would say no, but it's a case of it depends, potentially. Babesh says, any way we can know which query were blocked in the last 3 days or so? So Funny John wants to say all of them, potentially, because blocking is just a natural part of what happens inside of the engine. The reality, though, is give me 1 second. It's typically not something that I would want to dig into at that level of granularity, right? I would define a threshold limit for blocking and say what queries were blocked longer than this, and the engine actually provides a mechanism for that. If you go to the instance properties, advanced, there is a property called the block process threshold. And what that does is it sets a threshold when the lock monitor is walking the lock hierarchy. Anything that was blocked over this threshold in seconds will generate a report. There's an extended event called block process report. There's a trace event for that. There's also a event notification that can be fired for that. And usually I say 20 seconds. Anything that's blocked longer than 20 seconds, let it generate a report. One of the challenges, though, is if you have a persistent blocking situation or you have excessive blocking in the engine, it becomes very chatty. If you set the block process threshold too low, let's say 5, every time 5 seconds passes, it generates a new notification. I usually do 20 seconds because the default .NET timeout is 30 seconds. So if something's blocked for 20 seconds, it's probably affecting my end user workload and I want to look at it. Can wait types be the reason of a deadlock? Yes, because when you have that blocking, it has a LCK M wait type associated with it, and then it includes what the lock mode is. So yeah, it does give you some information about that. Any new enhancements to prevent deadlocks in 2019? The answer there, not that I know of at this point. So are there any other questions?
Hey, John, looks like we're all done.
All right. Well, thank you for attending. And, if you run into me at a conference, hopefully we can talk sometime. And thanks again.
Thank you. Thank you very much, John. And friends, this is probably the most deep dive session I have ever seen on deadlocks. And I hope all of you have thoroughly enjoyed this. So Jonathan would love to know that today we had close to 155 people joining this webinar from 31 countries. So that is incredible. Thank you, all of you attendees who have joined today. And thank you, John, for taking out time from your busy schedule to deliver this webinar for us. And here is a small ask from the DPG team. We will post a webinar pic on LinkedIn and Facebook. So please post your feedback and comments there. We would love to read your feedback and comments. If you have more questions, these are some forums and groups that you can join. Well, there are worldwide forums, but these are the ones that we moderate and manage. So go ahead and post your questions there. A quick word from our sponsors. Just like we do all these webinars and in-person events free for you, our another initiative, SQLMaestros, has put up a few short masterclasses on various topics like SQL performance, database DevOps, BI, machine learning, artificial intelligence, and it's a pool of international experts. Many of you would probably know many of them. These are all world-renowned MVPs and MCMs. So the contact details are there on the right panel, SQLMaestros.com, or just drop an email to classes and we'll reach back to you. It's always great to watch demos and watch videos, but if you want to try out a few things yourself, which I say the best way to learn is to do it yourself, there's a hands-on lab service that we conceptualized, and this library has more than 120 labs. So just go ahead and create your account and freely download some of these labs for yourself. These are all under SQLMaestros. So thank you very much for your time, friends. Once again, youtube.com/SQL Server Geeks is where you will see this recording up in next few days. Follow us on Twitter, SQLServerGeeks.com. And yes, visit dps10.com to learn more about our upcoming conference next year. We sincerely hope that Jonathan can join us if his schedule permits. It's a long flight from US to India, but yeah, let's see. So John and all of you attendees, thank you very much. Special thanks to the eDominer teams who have supported us in putting this webinar and all other events together. Have a good day, good night, wherever you have joined from. Thank you.